Alrighty, in this video, we are going to go over the structure, the directory structure of an Android application. Now, this is something I especially don't want to do inside of the IntelliJ IDE, or the Android Studio IDE. And the reason for that is as you may have seen in the Android Quick Start, the Android Studio actually gives us a sort of decorated view into our project with a lot of conveniences built into it. However, I really want to show the raw folder structure of it, which you could see in Android Studio, I'm sure, I know you can. There's a window for that, but I kind of wanted to show it in Explorer for added effect. Especially, and I also want to show it using the built-in or the default template for Android. Okay, so I'm going to go ahead and open up my folder over here on my left-hand side. We're going to be using Windows Explorer kind of as our own little IDE here for a little bit. An IDE without an IDE. And let's go down all these folders. So we have our Gradle folder. So you saw that before. The Gradle folder is basically just going to contain things like some properties and some cached files and just some other garbage Gradle stuff that we don't care about. So if you're familiar with POSIX operating systems, whenever you see a dot in front of a file or folder name, that typically means it's a hidden file that's only used by software and isn't really intended for you to manipulate most of the time, if at all. Next up, we have the build folder, which we already talked about the build folder. The most interesting thing about the build folder, other than having our builds, is, of course, the generated R file, which we'll be using this file all the time, and it's really cool to see how it's generated and where it's placed on the file system. But, I mean, maybe you guys don't think that's cool, but I do. Next up, we have the Gradle folder. Now, the Gradle folder just contains Gradle configuration as well as the Gradle wrapper, and that's it. Well, actually, all it contains here is the Gradle wrapper and its corresponding properties file. Not terribly interesting. Then we have our source folder. So our source folder is where things get fun. When I open up the source folder, we see we have Android Test and Main. And Android Test and Main have a Java folder, and Main has a resource folder as well, in addition to a Java folder. So you might be wondering, it's really interesting. Like, I open up this build.gradle, and you said that it's this that this build.gradle describes everything about how our project is built. Why do we have this Android Test and Main? Where did these names come from? Why do we have Main? How does it get picked up? The answer to that question is it's a convention that you can override if you wish, and it's something that's built into the Android tools themselves. Now, interestingly, we are not going to just have these two folders for our final project, because these two folders, basically, you can think of them as their own self-contained little bits that don't necessarily relate to each other. Our Android test folder has a Java folder within it, which, not surprisingly, contains Java code. And inside here we have our main activity test, which if we opened it up, we'll see that it is a scaffolding for some unit testing. It's an activity instrumental test case 2, is what it is. And so this bears not a whole lot of relation to main, because the Android test is simply basically just think about it as our unit testing project. So think about it kind of as a separate project, entirely separate from our actual Android application, even though it depends on it. If you are familiar with how C# does unit testing, just think of it as a unit testing project. And then we have main. Now, what is main? Main is where all of our Java code and resource files go into. Now, you might be wondering, why do we have a source and then main? Why can't we just not have this source folder and just have a main source folder where all of our Java code goes into? And the answer to that is you can technically have more than one of these kinds of folders. You can have more than just main here that can get merged together with main in order to produce what are called flavors. We'll talk about flavors in the next video, but bear in mind that is why there's a differentiation between source and main, so that we can have more than one folder down here and things don't get cluttered. Anyway, so main is where our Java code lives, and for all intents and purposes, unless we have a different product flavor, these are really the only files that we'll care about most of the time. And it contains our Java and our res and our Android manifest. Let's go through them from the top down. The first thing here is Java. So, Java. I don't know how many of you guys are familiar with how Java compiles code. A couple interesting things about the way Java does compile code is that Java enforces that certain classes are in certain folders. So we have package names, what are called package names or packages. And packages are basically just namespaces. And packages are typically done in a reverse domain. So that's why you'll often see things like com.company.thing or org.nonprofit or open source project.thing, where you use a reverse domain in order to produce your package name. Now, in Java, those periods specify sub-namespaces or sub-packages, and when you have a package, your package location on your hard drive has to physically match the folder that it's located in. So it's kind of an interesting aspect to Java that you don't see in a whole lot of other languages. So I guess other than PHP, which PHP, because of the way the class loader works, is commonly more efficient to match your namespace names to your locations. But in Java, it's required. And if we open up Java, this is where we start from. This is where our Java code starts, right here. So we could certainly go in, and if we wanted to have like a third-party library that we wanted to dump into our project that we depended code on for, we could just go ahead and dump in like another org dot or another com dot or whatever. This is where any code inside of this folder is going to be compiled by the Java compiler. So, yeah, this is the build path of the project. So under com, we have another subdomain, buzz, and under buzz, we have another subdomain, test1. So again, the reason why it's named like this is com is the TLD, top-level domain, buzz is the domain, and test1 is the project name, and that's why I named it like that. So inside of this, we have our main activity.java. So I'm going to go ahead and right-click and say Open with Sublime Text 2, and you'll see an activity similar to what we had before in the Android Quick Start. Now, it's not as advanced as the template. It doesn't have a menu and anything like that. It's just a really basic main activity, and all it does is it creates a view, and that's it. We'll talk about that in a later video when we talk about activities. But, again, I defined activities before. You guys should have a good idea of what they are. So that's our Java code. That's where all of our Java code is going to live. It's going to live under one of these folders, be it main or something else, and then under Java, and then under the corresponding package name. I do want to point out on this main activity.java, though, notice at the top it says package com.buzz.test1. This has to match the directory structure. You can't have this not match the directory structure or it'll fail. And you'll also notice it's interesting because unlike C#, we don't open up curly braces and extend to the rest of the file. So one of the reasons for that, or one of the consequences of that, is that you can only have one class per file. You'll also notice that main activity is the name of the class, and that is also the name of the file. That is also a requirement of Java. Anyway, so stuff things. Let's go ahead and close this out, and let's look at the next item down on the main list here. So we have res. Now, res is short for resource, and if we open it up, we'll see a bunch of stuff, a bunch of folders. We'll see our drawable folders, our layout folder, and our values folder. Now, this isn't a video about resources, but resources are going to be something that we're going to introduce kind of slowly throughout the series. Whenever we need to talk about a different kind of resource, we'll go ahead and implement it. But I guess since we only have a handful of resource types in front of us, I can at least explain what's going on, at least with the drawable context, where you see multiple of the same folder, just with different prefixes. Well, drawables typically contain things that can be drawn, which is really not surprising given the name. But you'll notice that we have these really interesting suffixes on the folder name itself. We have LDPI, MDPI, HDPI, and XHDPI. If you click into them, like for example LDPI, you'll notice they all have the same file in it that's named the exact same, IC Launcher, which happens to be the default name of what's used as the icon for the launcher. In Android, most icons are prefixed with IC underscore, and then launcher specifies that this is the launcher icon. And it's used... this doesn't specify that it's the launcher icon, but elsewhere in the app, it specifies that this icon should be the launcher icon. So notice something interesting as I go through these folders. So I'm in LDPI. Now let's look at MDPI. Now let's look at HDPI. And now let's look at XHDPI. Notice something interesting about the icon is that it keeps on getting bigger. So that should give you a hint as to what L, M, H, and XH mean. The first one stands for low DPI screens, or low dot per inch screens. Then we have medium dots per inch screens, high dots per inch screens, and extra high dot per inch screens. So basically what we're talking about is the resolution of the device. So high density screen versus a low density screen. And so why is that important, and is this a convention, or is there code elsewhere that switches between these different files depending on the density of our screen? The answer is no. The answer is this is an actual feature of Android. Android will go about choosing which resource to load depending on different parameters of the device that we're on. So what we can do here is we can have our drawable. So we have all of our drawable resources in this drawable resource folder, and they all have the same name inside of them. But depending on the density of the screen, Android will choose a different resource to use. So that's really cool, and this applies to a lot of things. A couple other interesting uses of this is we can have our layout resource, for example. We could create another layout folder, such as layout-SW600. And this layout folder, SW600, is screen width 600. Meaning, if any layout, if I'm on a device that has a screen width of 600 or greater, it'll use a layout that I specified here. If it can't find a layout specified in here, or I'm using a screen device that's lower than 600 pixels wide or 600 dp wide, we'll end up in using the resource that was specified by the normal layout folder. So that's how we can override different layout or different resources depending on a variety of parameters. It's not limited to just the density of the screen as far as pixels go. You can also specify things such as screen width, the orientation of the device as it is currently. You can also specify things based off locale and a bunch of other specifiers that you can use, so that you can make your code, make your code work on a large variety of devices and a large variety of configurations at one time very easily. Anyway, that's why we have the HDPI, LDPI, MDPI, and XHDPI. When we jump into Android Studio shortly, or not in this video, but in an upcoming one, I'll show you how this gets rendered in the Android Studio project window itself. Anyway, then we have our layout folder, and our layout folder contains, well, our layout, and that's right there. We talked a little bit about layouts in the quick start, so I won't go over them again. Then we have values, and under values we have strings.xml, and if I open this up with Sublime, you'll see that we have a string here called app name. Now, strings.xml is an XML file that specifies strings. Not surprisingly. It's basically like a dictionary, where we can have a string, we can refer to it with a certain token or identifier, and we can give it a particular value. So why is the strings.xml important, and what is this values folder? Well, the values folder itself contains a bunch of these XML files, or can contain a bunch of these XML files, and a variety of different resources. We can specify dimensions, we can specify colors, we can specify styles and themes. We can specify a lot of different things inside of these XML files. combined with the ability for Android to choose resource files based off of different parameters, such as locale or screen orientation, we can change declaratively, not programmatically, but declaratively alter different parameters based off of where a device is running and the current configuration of that device at that time. So that's a really cool feature. This is, for example, how you provide localization. You would have a strings.xml for every localization you wanted to support. And then you would use these different resource qualifiers on the different folder called strings or values dash blah, and like values dash fn or whatever, and have, or fr, and have your French locale load up completely different strings than your English locale or your default locale without having to write any localization code itself. So that's a really cool feature. Anyway, values just contains a bunch of XML files, and these XML files can declare a variety of different kinds of values. It's not just limited to strings, but you've seen they helpfully create this strings.xml file for us automatically, containing our app name, by the way. And they do that so just as because you might want to separate your dimensions and your styles and your other kinds of resources into different XML files, although you don't have to. But strings is a convenient location to place your strings. Okay, so now we have talked a little bit about our Java and Res. So just want to give a quick overview. The specifics of how we use these folders will be elaborated on when we need them, when we write features. But I don't want to scare people away from them when we get into starting to use those features. I would rather people have a quick little overview of what is in those folders and why they're important. The final thing I wanted to talk about here, as far as the project structure, is the Android manifest.xml. So let's go ahead and load that up and see what it looks like. So, yeah, this is the Android manifest. What is the Android manifest? Well, the Android manifest, aptly named, is an XML file that describes the contents of your Android application. Now, what do I mean by contents? Well, describe contents and metadata. But as far as contents, Android has a handful of base classes that we use to interface with the operating system. It has a handful of things that it understands about that we subclass in our code so that we can hook into the operating system. You've already seen an example of one of them, and that's the activity. So an activity is a base class provided to us by Android, and it allows us to interface with Android through the Activity API. And Android knows how to instantiate it, how to create it, how to manage its lifetime, and on and on. So the question is how do we tell Android about the things we have done that it should know about? Because an activity isn't actually the only thing that we can subclass and hook into Android with. We also have things like services, for example, or content providers, or a slew of other things, integration points that we have with the Android API. So how do we let Android know about it? Well, with this. The Android manifest will describe virtually every class that needs to be hooked into Android in some sort of way. Now, not all classes are going to be made or put into the Android manifest. For example, if we create a custom view type, or we create a model class, or a DTO class, or a service layer, we're not going to have to plug it into the Android manifest. Oh, by the way, I said service layer. I don't mean Android services. I mean service layer in the SOA perspective, the service pattern, where you have a class that's responsible for doing something. So if you have a service layer, you won't have to hook it up into the manifest. Only things that Android needs to be aware about enough to be able to, for example, instantiate it, you would put into your Android manifest. So that brings us to what we have right here. Our activity, I'm kind of starting inside out here, but that's okay. We have our activity element right here. We say activity, Android name equals main activity, Android label equals string app name. So that's the label of the activity, how you refer to it by name. And you'll notice it's referring to @string. So remember how in the first video, or the quick start video, we talked about the symbol and how it means resource, because we had to create new resources to make IDs for our views. Well, here this @string is referring to a string resource. Notice how it doesn't have a plus in it, like we did with our IDs. That's because we're expecting here to connect to an existing resource, and we are not creating one. So we're connecting to an existing resource called app_name. Now that should sound familiar to you guys, because we've specified it in our strings.xml file. So if we go back to the strings.xml file, which is located under our res values folder, we'll see that we have this string, and it's called app_name. Underneath the activity, we have our intent filter. We'll talk about intent filters later, but just think about this code as defining the entry point of our application. What is the first activity to be launched when we click on the icon inside the launcher? And in this case, it's going to be this activity, the main activity. If I created a new activity, I would not supply the intent filter that gives it main and launcher, because, well, I don't want to have two entry points in my application. Okay, so that's activity. So let me go ahead and separate that out a little bit, because we just... why don't you have... Why can you collapse on intent filter but not activity? Come on, Sublime. Anyway, so that's our activity. We need to make our Android aware of it. Up next, though, above it, we have our application node. And our application node hooks in the name of the application right here with string app_name, as you saw before. But it also hooks in the icon. By doing Android:_icon specifies how this should appear in the launcher. So that's what I was saying earlier in the resources folder when we were talking about IC Launcher. It's not because it's named IC Launcher that it gets to be our app's icon. It's because the manifest specifies the icon as @drawable, again, referencing a drawable resource, /IC Launcher, which is the name of that PNG file that's in all those different folders. And then finally, we have our actual manifest element. So up here, we see that package is COM_BUZZ_TEST, and we see that the version code is 1 and the version name is 10. So, not surprisingly, this just specifies the package name. Remember, the package name is the unique identifier of this application on an Android operating system. And then we have our version code and version name, which just tells, for example, Google Play Store or the Settings app on Android what version our application is currently on. And that's really about it. And as far as the Android manifest, there's a lot of other cool stuff we can do with the Android manifest, but we'll be talking about it later. For example, if we need anything, any system resource, we have to ask for it inside of the Android manifest. If you use Android at all, and you've ever installed an app from the Play Store, you might have noticed how whenever you install an app, it says, blah, 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 request the following permissions. You know, like, keep microphone on even if phone is turned off, stuff like that. And it'll ask you to hit OK. Well, the Android manifest is what specifies those permissions. So, a lot of permissions like accessing the internet or accessing the camera needs to be specified in the Android manifest in order to be able to use those features. So, yeah, I guess we can wrap up this video with one small thing. I want to show you guys the creation of an activity from scratch. I know you guys are getting probably pretty sick of my whole from scratch bit here with these last couple of videos, but I really want to do this. I just want to show you guys how to create an activity from your command line, or not from your command line, but from Windows Explorer and a simple text editor. So, let's get started. I want to hop over. The first thing I want to do, the first thing I want to do is I want to go into Java, COM_BUZZ_TEST1, and I want to create a new activity class. That's the first thing I'm going to do. So I'm going to say new text document other activity.java, and I'm going to hit enter, or spacebar rather, and then I'm going to drag it over, and I'm going to go ahead and write it. So we're going to start off with package com buzz test1. Then we're going to say import android.app.activity. Then we're going to say public, that's important, class other activity extends activity. So you see here how we extend or use the word extends instead of the simple colon in Java, as opposed to C#. Next up, I'm going to say override public void on create bundle saved state. I already have a mistake in this file. So I say public void on create bundle save state, but I never imported the bundle class. So up at the top of the file, I'm going to say import android.os.bundle. Once I've done that, the first thing I need to do is I need to say super.onCreate saved state. It's very important when working with Android code, when we extend something that's been provided for us by the Android framework, that we call through to its superclass. The final thing I want to do is set content view R, capital R, dot layout dot other. So again, we haven't, well, not again, but we haven't yet created the other layout XML file yet, but we're referencing it here for now, just so we don't have to go back to this activity. Okay, so now that I have that out of the way, I have my activity written. Let's go ahead and let's jump into our res folder. And inside here, I'm going to go into layout, and then I'm going to right click in layout and say new text document, and I'm going to say other.xml. So in other.xml, I'm going to open it up here. I'm just going to say frame layout. We haven't used that yet. And then I'll say XMLNS, which is required, Android equals http://schemas, schemas, Android com apk res Android. Then I'm going to say Android layout width match parent. I'm pretty sure I spelled that the first time correctly. I don't know why I went back and wrote it again. Layout height equals match parent. Then that's about all we need there. And then I'm going to go ahead and close out that tag. Then I'm going to open up a text view, and I'm going to have Android layout width equals match parent, and Android layout height equals match parent, and Android text equals, this is the other activity, and then I'm going to say Android layout gravity equals center. Okay, so that's our XML file. Took a way more keystrokes than I'm used to for a layout XML file, so excuse my slow typing speed there. But just wanted to make sure I spelled everything correctly, because typing without an IDE is actually kind of difficult sometimes. Okay, so what I'm going to do now is I'm going to, now that we have our activity class created in the correct folder, we have our other XML file created in the correct folder, I'm now going to hook our main activity up with our other activity. And I'm going to do it in the exact same way that we did before, when we created in the Android Quick Start, when we created a second activity that was launched by a button. So I'm going to open up main.xml right here, and under the text view, I'm going to say button. And for button, Android layout width is going to be fill parent, and Android layout height is going to be wrap content, which just reminds me, I made a mistake on that text view. We'll fix it in a second. Then I'm going to say Android text equals press me. And then I'm going to say Android on click equals launch other activity. Okay, so that's my button. And for some reason it's not highlighting it correctly, but you know what, that's whatever. Anyway, so now I have my main.xml. I added a button to it. It says press me, and then I have on click equals this method that we haven't written yet on our main activity. But in other.xml, I made a mistake of having the text view have a layout width of match parent and a layout height of match parent. Really quickly, we haven't talked much about layouts yet, but this isn't going to give me the behavior I want because I have it floating in the center of its parent, but then I have it stretching all the way on the parent, which means the text isn't going to be centered. I can fix that by giving the layout width a value of wrap content and the layout height a value of wrap content. I don't know why I started typing in weapon or wrapping. Anyway, so we'll go ahead and fix that real fast. Now, really, the last thing we have to do is we have to go back into our main activity and actually add the launch other activity method on it, which will launch the other activity. So let's go ahead and do that. I'm going to back out of layout, and then I'm going to back out of res, and then I'm going to launch Java, com, buzz, test1, and I'm going to take main activity, I'm going to open it. Inside of here, I'm going to say public void launch other activity view. Now, also, I don't know why that's not following the standard Java conventions right there. So I'm going to go ahead and write this code, and then I'm going to add the imports at the top of the file. So I'm going to say intent equals new intent this, comma, other activity dot class. So we're going to create an intent that launches other activity, and then I'm going to say start activity intent. So we're going to need to import two things. We're going to need to import view, and we're going to need to import intent. So let's go up to the top of the file and say import android.view.view is where the view class is located. And then we'll go ahead and import the intent, which is located in android.content.intent. It's really not fun not writing Java in something that isn't an IDE that can't import stuff for us. Anyway, so here is our main activity. So let's go ahead and launch this. Now, this shouldn't work, and hopefully you guys can at this point guess why it shouldn't work, but I want to show you guys it not working first. So I'm going to head all the way back up to the app1 folder. I'm going to shift right click and say open command window here. And I'm going to do Gradle W install debug and hit enter. And this will go ahead and compile it. Now it should compile, but it shouldn't run very well. Build succeeded. Come back over here, hit the little thingy, come here to main activity, launch it, and then when I hit press me, we get an exception. Now, quick thing, what if you wanted to know what the exception was? Just this is a really quick side note. Well, if you wanted to know what the exception was, you would use the logcat, which is available in the monitor. Remember how I talked about the monitor? It's a really nice debugging tool. Well, one of the things it shows us is it shows us the running log on the Android device so we can debug things like this. Now, fortunately, Android Studio has a built-in version of logcat, but we can launch it manually if we wanted to. I'm going to open up a new Explorer window, and I'm going to open up my SDK by going to C, Software, Android. I'm going to go into Tools, and I'm going to double-click on monitor.bat. Then I'll minimize this and wait 20 years for a Java application to launch. Oh, that was fast for a Java application. And then down here, we see logcat. So logcat will show us all of the log messages that are currently being printed out from our device. So what I can do is I can come here, and I can go over here to main activity, and I can press the button, and check that out. We have an exception. Now, this exception should be pretty straightforward. We see fatal exception, illegal state exception, could not execute the method of this activity. Are you going to give us a better... Here we go. Caused by Android.content.activity not found exception. Unable to find explicit activity class other activity. Have you declared this activity in your Android manifest? So the answer to why this shouldn't work is that we created this new activity, but we never declared it in our Android manifest. So that's really easy to fix. We'll close out of the monitor and move this to the side, and I'm going to open up source, main, and then Android manifest, which I think I already have open. Yes, I do. And then under the application element, I'm going to say activity, Android name equals, and then I'm going to say other activity. And then I'm going to close that off, and then I'm going to run this. So you see, all I did was I added a new element called activity, and I gave it a name. Because there's going to be no intent filters for this activity, I didn't need to specify any. So let's come back over here. Let's open up main activity, do press me, and look at that. This is the other activity. And I can hit back, hit press me again, and it says this is the other activity. So, yeah. That's Android. That's the project structure. That's how we use the command line, or some of the command line tools, to work with Android development. That's how we add new activities manually, which I will probably be very likely adding all of the activities we're going to be using manually throughout the series. It's good practice, and also, I don't really like the default blank template. I might go out of my way and make my own template, because I know you should be able to do that. I saw in the SDK somewhere something about that, so we'll see about looking at that later. But, yeah, all we did, just to recap this video, we talked about the project structure. We talked about basic resources and how they're loaded in. Then we went in, we manipulated our main layout view, and we created a new activity with its own layout view, and the activity itself only performs the setContentView operation, which tells it which XML file to use. And then in main activity, we launched the other activity when we pressed a button, and that's really about it. Okay, so there's really only going to be one more video left in this short little introduction to the internals of the Android build system, and that's how we deal with flavors. And then after that, we'll hop into Android Studio and actually get building the app. So we'll see you guys in the next video.